everyone, welcome again. In this video, I am going to discuss important university questions on Z transform based on combination formula NCR. So first we define binomial expansion. As we know, the binomial expansion formula is given by the binomial expansion of 1 plus x whole power n is 1 plus nx plus n into n minus 1 upon 2 factorial x square plus n into n minus 1 into n minus 2 upon 3 factorial into x cube plus n into n minus 1 into n minus 2 into n minus 3 upon 4 factorial into x power 4 and so on. So this we already know, and this is known as binomial expansion. Now we write this binomial expansion formula in terms of combination formula NCR. So in terms of combination formula, we can write this binomial expansion as 1 plus n, we write nc1 into x plus n into n minus 1 upon 2 factorial. This we write as nc2 into x square plus n into n minus 1 into n minus 2 upon 3 factorial. This term we express as nc3 into x cube plus so on. So this is the expression of binomial expansion formula in terms of combination formula, because we know that the combination formula NCR is equal to n factorial upon r factorial into n minus r factorial. So for NC1, here r equal to 1, then NC1 gives n factorial upon 1 factorial into n minus 1 factorial. Now 1 factorial is 1, n factorial we can write n into n minus 1 factorial upon 1 factorial, which is 1 into n minus 1 factorial. So here n minus 1 factorial cancel, 1 factorial is 1, so we get n. So nc1 gives n. Similarly, nc2, for r equal to 2, we get nc2 is equal to n factorial upon 2 factorial into n minus 2 factorial. Further, we write n factorial as n into n minus 1 into n minus 2 factorial upon 2 factorial into n minus 2 factorial. So here n minus 2 factorial cancel, and finally we get n into n minus 1 upon 2 factorial. So we write n into n minus 1 upon 2 factorial as nc2. And similarly for r equal to 3, we get nc3, which gives n factorial upon 3 factorial into n minus 3 factorial. And we write numerator n factorial as n into n minus 1 into n minus 2 into n minus 3 factorial upon 3 factorial into n minus 3 factorial. So n minus 3 factorial cancel, and we get n into n minus 1 into n minus 2 upon 3 factorial. So in place of n into n minus 1 into n minus 2 upon 3 factorial, we can write nc3 and so on. So this is how we can express binomial expansion formula in terms of combination formula. Now we discuss few important questions on binomial expansion and combination formula for Z transform. So our first example is, find the Z transform of MCN where n is greater than equal to 0 and less than equal to m. So that is, n is lying between 0 to m, and we have to find Z transform of MCN. So given un is MCN where n is lying between 0 to 1, and we have to find its Z transform. So by definition of Z transform, we know that Z transform of the sequence un is summation n goes from 0 to m, un into z power minus n. So z transform of MCn is summation n goes from 0 to m, because n is lying between 0 to m. Summation n goes from 0 to m, un is MCn into z power minus n. So by definition of z transform, we get this result for z transform of MCn. Now for expand this summation by putting n equal to 0, 1, 2, 3 and up to m, we get, for n equal to 0, we get MC0 which is 1 and z power 0 is 1, plus for n equal to 1, we get MC1 into z power minus 1, plus for m equal to 2, we get MC2 into z power minus 2. For n equal to 3, we get MC3 z power minus 3 and so on, and up to m we get MCm z power minus m, and MCm is 1. So this expansion, this is what, 1 plus MC1 z inverse plus MC2 z minus 2 inverse square plus MC3 z inverse cube and so on. So this is what, this is the binomial expansion of z inverse. So we can write this expansion is 1 plus z inverse whole power m using the binomial theorem. So we compare this to the definition of binomial theorem in combination formula. Then we have 1 plus MC1 z inverse plus MC2 z inverse square plus MC3 z inverse cube and so on, z power minus m. So which gives the binomial expansion 1 plus z inverse whole power m. Next example is very important. Find the z transform of m plus n Cm for n greater than equal to 0. So given un is equal to m plus n Cm for n greater than equal to 0. Now by definition of z transform, we know that z transform of the sequence un for n greater than equal to 0 is, z transform of un is summation n goes from 0 to infinite un into z power minus n. This is the definition of z transform for n greater than equal to 0. Now putting the value of un, m plus n Cm, we get z transform of m plus n Cm is equal to summation n goes from 0 to infinite m plus n Cm into z power minus n. Now we use a property of combination formula that NCR is equal to NCn minus R. So here m plus n C and n minus R give m plus n minus m. So we get n here. So using the property of combination formula that NCR is equal to NCn minus R, we get summation n goes from 0 to infinite m plus n as it is. C, here we have n minus r, so m plus n minus m, we get n here. So we have m plus n Cn into z power minus n. Now putting the values of n 0, 1, 2, 3 and so on, we expand this summation, then we get for n equal to 0 we get MC0 which is 1 and z power 0 is 1, so we get 1, plus for n equal to 1 we get m plus 1 C1 z inverse, plus for n equal to 2 we get m plus 2 C2 z power minus 2, plus for n equal to 3 we get m plus 3 C3 into z power minus 3 plus so on. Now we write Using the combination formula that NCR is n factorial upon r factorial into n minus r factorial. We expand this NCR formula, then we get 1 plus m plus 1 C1 gives m plus 1 into z inverse, m plus 2 C2 using n factorial upon r factorial into n minus r factorial, we get m plus 2 into m plus 1 upon 2 factorial z power minus 2 plus again we expand m plus 3 C3 using NCR n factorial upon r factorial into n minus r factorial, we get m plus 3 into m plus 2 into m plus 1 upon 3 factorial into z power minus 3. Now we write this expansion as 1 plus, here we write negative m minus 1 into z inverse we express as minus z inverse, then we get same term m plus 1 z inverse. So we express in form of this minus m minus 1 into minus z inverse plus, here we write minus m minus 1 into minus m minus 2 upon 2 factorial minus z inverse whole square. So negative common, then we have positive, we get m plus 1 m plus 2 upon 2 factorial. Here minus square is plus and z inverse square is z power minus 2 plus we write minus m minus 1 minus m minus 2 minus 3 upon 3 factorial into minus z inverse whole cube. So here negative common, then positive, and here negative common, then we have negative term m plus 1 m plus 2 m plus 3, and here we have minus z inverse cube is minus z power minus 3. So negative is again positive, so we get m plus 1 m plus 2 m plus 3 positive by 3 factorial into z power minus 3. So we express this expansion in terms of negative m. Now this again using the combination formula, these terms are what? These terms are 1 plus, this is minus m minus 1 C1 z power minus 1 minus z inverse plus here this term is what? Minus m minus 1 C2. This term is what? Minus m minus 1 C2. Then minus z inverse square plus this term is what? Minus m minus 3 C3 minus z inverse cube and so on. So we get 1 plus minus m minus 1 C1 negative z inverse plus minus m minus 1 C2 negative z inverse square plus minus m minus 1 C3 negative z inverse cube and so on. So this expansion is the binomial expansion, like 1 plus MC1 x plus MC2 x square plus MC3 x cube and so on. So the value of m is minus m minus 1 and the value of x is minus z inverse. So this is the binomial expansion of 1 minus z inverse whole power m minus m minus 1. So we get, this is the binomial expansion of 1 minus z inverse whole power minus m minus 1, and which can be expressed as 1 minus z inverse whole power negative common m plus 1. So this is the required Z transform, and in next video we will discuss inverse Z transform. So this is an important example. So see you in next video. Thank you.